So hi everyone, let's take a look at Leetcode programming problem number 32, longest valid parenthesis. So this is a Leetcode hard problem, and indeed this is a bit of a tricky problem. The problem goes as follows. We are provided with an input string which just has opening and closes parenthesis, and we have to find out the longest valid parenthesis in it. So for example, the example that they have provided in over here. So here you see that there is this length 2 substring of this input string, which is a valid parenthesis. So and its length is 2, so its answer would be 2. Similarly, if you see this example in over here, we have this substring which is of length 4, which is a valid parenthesis, so this would be the answer. So how about we solve this? So the approach which I had be discussing is a stack based approach. Let's see how this approach would work. So herein I have taken an example input string which kind of covers most of the cases which are possible on over here. So two things to note in over here. First thing is that whenever you see an opening parenthesis, then the case is easy, you just push it to the stack. So when you see this, you just push it to the stack. When you see a closing parenthesis, then there are different scenarios which could happen. One scenario is that the top of the stack is an opening parenthesis, which is simple. In this case, this open and close match, and we push a length of 2 back to the stack, because this open and close pair would make a string of length 2. Second case is there is a nested parenthesis. So in that case, you would encounter at the top of the stack some number, let's say a number like 2, which denotes that there is already a length 2 substring which has a nested parenthesis between this closing parenthesis. So in this case, we would have to kind of go through the stack, pop elements till we find an opening parenthesis, and then we would know that we have found the whole nested parenthesis. Okay. Third case would be that the stack is empty itself and still you get closing parenthesis. In that case, we will just ignore these closing parentheses because they cannot anyhow make a valid balanced parenthesis substring. So let's take this input string and put this approach into practice. So I'll first of all maintain a stack. So first of all, we get this opening parenthesis. So this is simple, we just push it in the stack. Then we move to over here. So we have a closing parenthesis. So we check the top of the stack. So it is an opening parenthesis followed by a closing parenthesis. So this case, we just pop this opening parenthesis and put in 2 over here, which means that we have found a substring of length 2, which is a valid balanced parenthesis substring. Let's move forward. Now again we get an open parenthesis, simple, we put it in the stack. Then we get another open parenthesis, again we put it in the stack. Then we get this closing parenthesis. So now when this closing parenthesis comes, we check the top of the stack, it is an open parenthesis, so open close match. So we pop out this open parenthesis and instead put 2, which signifies we have found a substring of length 2, which is actually this length 2 balanced parenthesis substring. Let's move forward. Now we get this closing parenthesis. Now this is an interesting case. So we have a closing parenthesis and the top of the stack is 2. So in this case, what we need to do is we need to keep on popping items from the stack till we find an open parenthesis. So we'll pop out this 2, we'll remove this, then we'll look at the top of the stack. So the top of the stack is now a closing parenthesis, which we were looking for. So now what we would do is that we will sum up all the elements which have been popped. In this case it is just one element 2 which was popped, and add 2 to it. So basically I'll add 2 to it. Why add 2 to it? Because I have found an enclosing open and closing parenthesis. If you see the example in over here, so this open and close, this one and this open and close parenthesis encloses the inner parenthesis substring of length 2. So totally we have a parenthesis substring of length 4. So we would now push that after we have popped out that opening parenthesis. So let me just pop this out and push in this 4. So we have come till here now. Now we have a closing parenthesis. Okay, so now we have a closing parenthesis. Again the same situation, we have integers, an integer at the top of the stack, so we pop it out. So we pop out this 4 and we remove it. Then we again check the top of the stack, so we again have an integer, we pop that out as well. So basically we pop out this 2 as well. So 4, 2 items have been popped out, and now my stack is empty and still I haven't find a opening parenthesis which I was looking for. So in this case, since I haven't found an open matching open parenthesis, so that means that this closing parenthesis for which I was searching for a matching open parenthesis is invalid. It doesn't have one. So what I would do is I will push back the items which I popped from the stack. So I'd push back this 2, I'd push back this 4 as well, right? And so I push them back. Let's remove this. Let's move forward. So now we come to this open parenthesis. This is simple, we just put it, and then we find this closing parenthesis. So again this is simple, we match it with the top of the stack which is open parenthesis and just push 2 in it. Right. So yeah, one thing which additionally we would have to do, which should be taken care of, that when we found out this invalid closing parenthesis, we would also push some marker element in it. Let's call it star, which denotes that when we found this matching parenthesis of length 2, before that there was one invalid closing parenthesis which is denoted by this. Now we have this stack, so we can now start popping from this stack and keep on adding up the values which we have popped till we encounter a marker. So first of all we pop out this 2 from the stack. Okay, and this 2 is gone now. Now when we again pop out, we get this marker popped out from the stack. Sorry. So now since this is a marker popped out from the stack, so we have a sum of 2 which is available with us, and this is the max that we have found till now. Now let's again pop out the next top item from the stack, which is 4. So let's pop out this 4. This 4 is gone. Then let's move forward and pop out the next top element from the stack, so which is 2. So we have this 4 and 2, and we sum it up, we keep on adding it up. So 4 plus 2 is 6, and now this, after this 2 is popped out, we have nothing remaining in the stack, and the max that we have found till now is 6. So 6 would be the output, which is the length of the longest valid matching parenthesis substring. So this is actually the right answer. If you observe in over here, we have this substring of length 6 which has all the parentheses matched. So if you would want to check out the programmatic solution for this approach, please check the link that I've added in the description. Thanks for watching.